Hi guys, welcome to day 3, or I guess day 1, 15.2. We're going to solve trig equations, so we're going to use a lot of what we know about the unit circle and inverses, put an equal sign in an equation, and solve for x or solve for theta. There are some, we have a trig identity that I feel like we've seen view slides. We're going to skip before. Actually, we're going to skip the trig identity. Okay, we've done this slide before, but I want to address something that I think can be confusing. And in order to do that, I'm going to change these problems to negative root 3 over 2 because without it doesn't show up as much. So I'm going to address the difference between asking what the arc cosine of negative root 3 over 2 is versus what is the cosine of, where is the cosine of x equal to negative root 3 over 2. Okay, this is an inverse function. It has a restricted domain. The answer can only be found between 0 and 2 pi. It's only one answer, and it's 5 pi over 6. Okay, the second question is asking where on the unit circle, and that can be in more than one place, is the cosine of x equal to negative root 3 over 2. And that would be here and here at 5 pi over 6 and at 7 pi over 6. So, Ms. Eichler, what's the difference? The difference is if the function starts with finding the arc cosine of negative root 3 over 2, or the inverse cosine of, they're the same thing, or the inverse cosine of negative root 3 over 2, that answer is only 5 pi over 6. If you put that into your calculator, you would only get one answer. You get a decimal that's equivalent of 5 pi over 6. But cosine of x equal to, you're going to get two answers. It's kind of like when I say x squared equals 16 and you say x equals plus or minus 4. That's a different answer than if I were to say, what's the square root of 16? Square root of 16 is just equal to 4. The math is the same, but the question, the way that they're posed are different. So just keep an eye out for that. So in this first one, there is no interval that I'm looking at. So my answers are, for example, sorry, this is such a mess. Example number 1, my answers are 5 pi over 6 and 7 pi over 6. However, there's no interval, there's no end to my solving, so it actually is equal to negative 3 pi over 2 infinite amount of times. Since I'm going to add 2 pi k and 2 pi k to 7 pi over 6, okay? Let's try example 2. So example 2, the difference is that we have 2x equal to negative root 3 over 2. So that means that 2x is equal to my two answers, 5 pi over 6 and 2x equals 7 pi over 6, which means that x is now 5 pi over 12 and x is equal to 7 pi over 12. Now, we've changed our period. Cosine of 2x means that if I take my period of cosine, which is 2 pi, and divide it by 2, my period is now pi. So the intersections are going to happen at 5 pi over 12 plus pi, or every pi k after that. So I'm going to rewrite and say that x is equal, let's try that again. Okay, so that means that x is equal to 5 pi over 12 plus pi k. Notice it's not 2 pi k because our period changed to pi. And then my second answer is 7 pi over 12 plus pi k. Now, the only reason that I'm using this pi k notation is because there is no interval at the top of the question. So I can say there's not just one intersection or two intersections, there's infinite amount of intersections. Now let's take a look at the difference between this and our next slide. Okay, we're doing something similar, but in this case, you can see the interval of 0 to 2 pi, so that all of the plus pi k or 2 pi k is not going to be relevant here. So I'm looking to see where the sine of x over 2 is equal to 1/2. So I would ignore the x over 2. Sine is equal to pi over 2. I'm sorry, 1 over 2. So sine is equal to 1 over 2 at, I'd say pi over 6. It's positive 1 over 2 and 5 pi over 6. Okay, so I'm going to do example number 1 over here. So I say that if that's the case, then we're going to take our x over 2 and set it equal to pi over 6. And then we're going to send our x over 2 equal to 5 pi over 6 and solve both equations separately. So if I multiply by 2, I get 2 pi over 6 or pi over 3. And for the second equation, if I multiply by 2, I get 10 pi over 6 or 5 pi over 3. Okay, that's step 1. Step 2 is to figure out your new period. So a period for sine is 2 pi. However, the b, it looks like, is 1/2. It's x over 2. Imagine that is 1/2 times x. So that means that the period is now 4 pi. So I think that I'm done because x equals pi over 3 and x equals 5 pi over 3. The period of this is 4 pi. So if I were to add the period onto those two answers, I'd be way outside the bounds of 0 to 2 pi. Okay, the other way to think about this is if I were to graph the sine function, which had a period of 4 pi, it would look something like this, right? And I'm trying to see where that function is equal to 1/2. Well, if you were to graph it, the sine function is only equal to 1/2 in 2 places. So the first 2 answers that I found were enough. Okay, so example number 2, first you start with where is tangent equal to -1. Tangent is equal to -1 in quadrants 2 and in quadrant 4 at what would that be? 3 pi over 4 and 7 pi over 4. So I'm going to say that pi x over 3 equals 5 pi over 4 in quadrant, just kidding. That should be 3 pi over 4 in quadrant 2, and pi x over 3 equals 7 pi over 4. And then we do a little cross multiplication. The pi's are going to cancel, and it looks like I'll get 9 over 4. And the pi's are going to cancel, and I get 21 over 4. Okay, little different question. So now I have to figure out the period. Well, the period of tangent is just pi. I'm going to divide that by pi over 3. If you multiply by the reciprocal, you're just going to get a period of 3. So, a little tricky. So if I were to add, let's think. So 2 pi is like 6.28. Okay, because we no longer have the pi's there. 6.28. So period is 3. So if I add 3 to 9/4, I just have to stay under 6.28. So if I add 3, that would be, what would that be? That would be, we'd get common denominators. So I get 12 over 4. 12 over 4 plus 9 over 4 gives you 21 over 4. Is that bigger than 6.28? I don't think so. Right? 6 times 4 is 24. No, then we're still under the bounds. Okay. So x equals, if I were to add 12 over 4 to this one, I would get 32 over 4. Is that bigger than 6? Yes. So the only answers that I have for this one are 9 over 4, 21 over 4, and 20. Oh, that's the same answer. So my only answers are 9 over 4 and 21 over 4. And just figure out where. The last kind of solving we're going to do involves possibly 2 trig functions, sine and cosine. So there's a couple of tips up at the top. Let's try them out. So number 1, we've got root 12 sine x equals 2 cosine x. My recommendation first would be to combine the numbers in any way you can. So if you divide root 12 by 2, remember root 12 is the same as 2 root 3, right? So if you divide it by 2, you get root 3 sine x equals cosine x. And then I would divide both sides by sine. Root 3, and I'll call that root 3 over 1 is equal to cosine x over sine x, which is cotangent. But I'm going to leave it just like this. Where in the unit circle is the x value root 3, or most likely root 3 over 2, and the sine value is 1 over 2 positive. And that's going to be at pi over 6. So x equals pi over 6. And it also happens at x equals 7 pi over 6. There's no change in period, and there's no interval, so we're going to have to use the pi k. So x equals pi over 6 plus 2 pi k. X equals 7 pi over 6 plus 2 pi k. Because there are infinite amount of places where those intersect. Okay, number 2. Number 2 doesn't look like anything on the unit circle. 7 and 11, not on the unit circle. So here's what I'm going to do. I'm going to divide both sides by 7, and this is just a strategy. And divide then both sides by cosine, because I know I'm going to use my calculator. I don't know 11 over 7 on the unit circle, but I do know that I can do tangent, inverse tangent to solve this. So in my calculator, I would do x equals the inverse tangent of 11 over 7. Since I did the other one in radians, I'm going to keep it in radians. 7 divided by 11. Since there's no guidelines in the, there's no interval, there's no guidelines in the instructions, you don't really have to do it in radians, but since my calculator is already there, I'm going to do this. So 0.56, maybe we'll go 2 decimal places out, so maybe we'll say that's 0.567. That is one place that tangent is equal to 11 over 7. And then we know that tangent has a period of pi. So we're just going to say 0.567 plus pi k. Now, I could add pi to 0.567 to get 2 answers, but not necessary in this case. We only need to find 1. If I added pi, it'd be redundant, and I'd get the same as my beginning answer. So we are in assignments. I think this first one was pretty straightforward. Let's go to the next slide, see if there's one that's a little bit more challenging. Maybe on this one, we'll do number 18 because we haven't seen a squared before. So why don't we go ahead and get rid of that square and take the square root so that we can set the sign of x equal to plus or minus root 3 over 2. Well, that one we know. So remember, and it's positive and negative root 3 over 2. So sine of x is equal to positive root 3 over 2 at pi over 3. Now, you could be lazy, and I'm going to be lazy right now, and find all of the places, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And say all of those are answers plus 2 pi k. You could also find just 2 of them and say pi plus pi k. So if I add pi over 3 plus pi, I get 4 pi over 3. And if I add 2 pi over 3 plus pi, I get 5 pi over 3. So I can eliminate those 2 bottom answers if I just added pi k, but this works too. They're both acceptable ways to answer the question. I like 24, but I'm going to work on 23 so that you can get ready for 24. I've got cosine on both sides, and you can't divide a 2x and an x. So I'm going to use a Pythagorean identity. So I'm going to switch out cosine 2x for 2 cosine squared x minus 1. If you remember that, Pythagorean equals cosine x. And I'm sure that you see, as I do, that this looks like a quadratic. So if we moved over that cosine x by subtracting it to the other side, it's got quadratic form. So if you can imagine, this is like 2x squared minus x minus 1, and we have to factor it. We could do that, and then I'm going to replace my x's with cosine x. So if I said 2x and x and 1 and 1, and to get the negative in the middle, it should be a plus and a minus. And then I'm going to swap that out with 2 cosine x plus 1 and cosine x minus 1. We're going to set each of those equal to 0. So we've got 2 mini equations. That means that cosine x equals negative 1/2 and cosine x equals 1. So where does cosine x equal negative 1/2? That's in quadrants 2 and 3. I think that would be at 2 pi over 3 and 4 pi over 3. Doesn't look like there's any restrictions on the interval, so we'll say plus 2 pi k plus 2 pi k. Cosine of x is equal to 1 at 0 and 2 pi, but when I say plus 2 pi k, that should take care of it. So that's 23. I want you to use that to do 24. And I think 52 is fairly challenging, but I want you to give it a shot, see if you can figure it out. Do all of the circled problems. If you have any questions, I'll be in a Google Meet. I will also be there if you had questions on the class kick for this morning or this afternoon. I will be there to help. So I will be there the entire time. Pop in anytime you want to just say hi or if you have a question. Talk to you guys soon. Bye.